Hi everybody, welcome to this video. Here we shall discuss independent events in relation to the probability theory. Suppose you're watching a coin toss in a game. Now think about it. Will the toss in today's game depend upon the toss in the previous game? I hope you agree that the answer is no. Because if not, we have much bigger problems to solve. So if that's so, then we can say that the two tosses are independent. In other words, today's toss is independent of all the previous tosses in history, thankfully. So if two tosses are independent, the probability of getting two heads in a row, that is a probability of getting a head, then another head, equals the probability of head times the probability of heads. That's a definition. In general, the probability of getting one independent event after another, say E1 and E2, is the product of their individual probabilities. So let's compute the probability of getting two heads. It's a fair coin, so the probability of heads equals to the probability of tails, and both of them are 0.5. So because each coin toss is independent of previous one, the probability of two heads in a row equals probability of getting a head times the same. So which equals to 0.5 times 0.5, and the answer is 0.25 or 25%. Similarly, consider a fair dice and compute the probability of getting 3 sixes in a row. Again, getting a 6 in each trial or each roll is independent of what went on previously. So we multiply the probability of getting a 6 3 times, which equals to 1/6 times 1/6 times 1/6. And the answer is 1/216. Now suppose there are 3 white and 3 green balls, and we randomly pick a ball, say with eyes closed. Now what's the probability of choosing a white ball? Well, it is the number of white balls over the total number of balls. So number of white balls, as you can count, is 3, and the total balls equals 6. So the probability is 3 divided by 6, or 1/2. Now suppose that's what happened and a white ball came out. Then we decided to replace it back in the group of balls. So I'm saying that carefully, and that's something that we will talk further about in this video and later. So we replace the ball back in. Now what's the probability of picking another white ball in the second attempt? I hope you can see that the probability remains the same. That is 1/2. This is because nothing has changed, and we still have 3 greens and 3 whites to choose from. Therefore, we can say that the event of picking a second ball is independent of the event of picking the first white. Therefore, the probability of picking 2 in the row is a product of probabilities. That is, probability of picking white the first time times the probability of picking white the second time, and they're both the probabilities are the same, and which equals to 1/4. Let's consider one last example of independent events now. This time we pick 3 balls randomly, one after the other. Suppose we want to measure probability of a sequence. First white, then green, and then another white. After each pick, we replace it back in the group. Hence, we get 3 independent events. So the probability of getting a sequence of white, green, and white equals the product of their probabilities. By using commas, we imply they came they came in that order. So which equals 1/2 times 1/2 times 1/2, which equals 1/8. So that concludes the discussion of the independent events. I'll see you in the next one where we'll discuss the dependent events.